Bismillahirrahmanirrahim. Today I wanted us to get a good working understanding of the vertical motion equation, which I have written over here. Now, even before we start talking about the vertical motion equation, we have to learn a bit of terminology that is associated with this vertical motion equation. Now, the vertical motion relates to any object that is either thrown or one that falls spontaneously, like an apple falling from a tree. So the vertical motion equation again applies to any object that is thrown or one that falls spontaneously, such as an apple falling from a tree. Now, any object that is thrown or falls, it's called a projectile. It is just a term that is used to refer to the object in question. And the path that it traces is called a trajectory. So in this case, the parabola is the trajectory of this projectile, like thus. So the object that is thrown is the projectile, and the path that it traces is called its trajectory. Okay? Now, the path of this basketball, as you can see, is a parabola. Okay, and it starts over here. The reason it starts over here is because that's where it's thrown. This is not a mathematical scenario. This is a real life scenario with a real game and real stakes in the basketball court, so to speak, right? So if we were, however, to place an x and y axis over here, this would be like the y axis, and this would be the x axis, and the origin would be over here like this. Okay, so this is the initial height. Okay, now there are two other very important things that we need to understand. First is the object height, that is the height of the object from where it is thrown. For example, like here, this is called the initial height. So this is s over here, and in this equation, s is the initial height of the object. Okay, now that will be different for different objects. So if a person is taller, the initial height may be different. If they're shorter, the initial height might be different. So that is the initial height of the object. And in the vertical motion equation, that is represented over here. So the s in the vertical motion equation is the initial height of the object, and that will vary upon the different scenario. The second thing that we also need to know is the initial velocity. That is the initial speed. Okay. As you can imagine, the path that the object will trace, the path of the trajectory, will depend on how fast it was thrown, right? The initial force that was imparted on this basketball. That initial velocity or the initial speed is represented in the vertical motion equation over here, and that's called v, or v sub 0. Initial speed or initial velocity. Now, what is the difference between velocity and speed? Now, speed is just how fast something is going. Okay, so let's say somebody's driving a car and they're driving is 35 miles per hour. So that's their speed. Now, velocity is 35 miles per hour in the direction of east. So velocity takes into account the direction of the movement. So in such cases, as you can imagine, the direction the basketball is thrown is very important. If the person turned around and threw the basketball in the other way, it might land in the other basket. So in such cases, the direction of movement is important. We talk about the velocity and not speed. So now we are ready to tackle this vertical motion equation. Now, look at this vertical motion equation. The vertical motion equation is an equation for the height of the object. So h here represents the height of the object. Now, as you can see in this graph, the height of the object varies. Over here, it's like this high, and then it goes a little higher, and then it goes a little higher. The height of the object changes, right? The height of the object is constantly changing, right? And to the point that it kind of misses the basket, and to embarrassment of the person who threw it. And the height of the object is constantly changing. The height of the object depends on the time. So this is the initial time, and sometime later, right? Like this. So the height of the object is constantly changing. So the height of this object depends on how much time has elapsed. The height of the object depends on how much time has elapsed. So the motion, the vertical motion equation, tells you the height of the object. Okay, height at any given time, at any given time. So if you wanted to know the height of the object at any particular time, the time of interest for you, you would substitute that time in the place of t, that's time. You would figure out how high the basketball is. Now, in this vertical motion equation, this -16 is particularly important, and that's related to the Earth's gravity. This object falls because of Earth's gravity. Okay, and in fact, this equation, the way it is written, is in feet per second. So the questions that you will see will relate to feet and seconds, etc. Okay. If you were on a different planet, the initial value here, -16, would be different based on the gravity of that planet. Okay. And then we have suggested that the v is the initial velocity that's particular and peculiar to that particular scenario. And s is the initial height, also particular and peculiar to that particular scenario. So v and s will change depending on the circumstances. So let's take this information that we know and write a specific equation. So let's say in this example that's given to us, the initial height was 6. In other words, the basketball was thrown from 6 feet high, and let's just say the initial velocity was 24 feet per second. Okay, so that's given information. Now, I could have chosen something else, but I just decided to choose that the basketball was thrown at 24 feet per second. Okay, then I could write the vertical motion equation for this scenario, and that would be like this: the height of the object at any given time, h of t, would be equal to -16 t squared plus 24t plus 6. Okay, plus 6. Now look, this vertical motion equation that I've written over here applies to this particular scenario with the details that are provided to us, that is the initial velocity and the initial height. Now what this vertical motion equation gives us is the height of the basketball at any given time. So for example, if I wanted to know what the height of the basketball is, let's say at when time is 0, it means the initial time right here, that would be t would be equal to 0. Okay, I would substitute 0 in place of t. If I wanted to, for example, know where the height of the basketball is 1 second later, I would substitute 1 in place of t. And if I wanted to find out where the basketball is 2 seconds later, I would substitute 2 in place of t. So again, the vertical motion equation gives you the height of the projectile at any given time, right? Let's just do this experiment right here. So what's the height of the object at time equals 0, initial time? Well, in that case, we would substitute 0 in place of t. So I have -16. Okay, so t is 0. Okay, then we have to square that. Okay, and as you can see, well, 16 times 0, and that even if it's squared, this is still 0. 0 squared is 0. So this term is basically 0. 24 times 0 is 0. So I'm left with 6. So when the time is 0, the height is 6. But we kind of knew that already. That's the initial height of the basketball, right? Now, if we want to know where the basketball is 1 second later, we would substitute 1 in place of t. So we would do like this, 1 squared, and then we would have 24 times 1. We would get -16 times 1 squared plus 24 times 1 plus 6, and that is -16. 1 squared is just 1, plus 24 plus 6, 14. So the basketball is 14 feet above ground 1 second later. Now how about 2 seconds later? Well, I'll just substitute 2 in place of t. So that's 16t squared plus 24 times 2 plus 6 over here. This comes to be -10. Now, what does it mean that the basketball is -10? Well, the basketball is not -10. Basketball has bounced off like this. But what this is saying is, this is a parabola, right? So if the ball were to continue like this, the ball would be like, continue like this, it would be like 10 feet below ground over here like that. That's what that means, okay? So this is a mathematical model, but we have to apply real life parameters to this mathematical model. So what this tells us that the basketball lands on the ground somewhere between 1 and 2 seconds, right? Because basketball is like 1 second after it's shot, it's at like 14 feet, and then like 2 seconds is like -10 feet, so it's below ground already, okay? Now look what we have accomplished so far. We have taken a particular scenario of a vertical motion equation where an object was thrown with some specific parameters or specific things to that scenario, such as the height being 6 feet and the velocity, initial velocity being 24 feet per second, and we wrote a specific vertical motion equation for that scenario. And we used that equation to find out the height of the object at any given time, 0 seconds, 1 second, and 2 seconds. Now, I don't know about you, but to me, I have two questions in my mind, okay? I'm trying to figure out. Now, I want to know, how long does it take for the ball to hit the ground, okay? So how long does it take for the ball to go from here to here, okay? In other words, how long will it take for the ball to hit the ground like that, okay? That's one thing I have in mind. The other thing I have in mind, I'm not going to tell you right now. No, I'm just kidding. I'm going to tell you. What I really want to know is, how high does the ball go up like this? What's the maximum height of the ball like that? Okay, I'm really curious about that. But how do we go about answering those questions? Well, let's take one at a time. How long does it take for the ball to hit the ground? Okay, well, the way to understand that is, look, we have the vertical motion equation over here, right? The vertical motion equation gives you the height of the projectile at any given time. What if I gave you the height, but I wanted to know time? In other words, so if I'm given the time, I could figure out the height. But if I'm given the height, right, I could possibly figure out the time, right? So watch. Here's the vertical motion equation for this scenario. So if I'm given time, I could figure out how high the basketball is. But if I'm given the height, I can figure out how long it will take for the basketball to reach that height. Okay, let's figure out first, before we get to this, how long will it take for the ball to hit the ground? I want to know, how long will it take for the ball to get to 14 feet? So I put 14 feet over here for the height. I'm going to do this, -16t squared plus 24t plus 6. Now look at this, I'm cheating a little bit because I just figured out that it will take 1 second for the ball, right? I put 1 for t, I got 14, right? So it'll take 1 second, correct? But I knew the answer kind of already, but I hope you saw that too. So, well, let's figure this out. The height is 14. Now we want to know how long it will take for it to do. Now, how do we go about figuring this out? Well, lo and behold, this is a quadratic equation. That's a quadratic equation, right? And we talked about how to solve quadratic equations. So there are 4 ways to do it, okay? One is graphing, one is factoring, and the third is completing the square, and the fourth is quadratic formula, okay? In questions like this, your best friend is going to be the quadratic formulas. So here it is, I've written out for you. The first thing I'm going to do is I'm going to subtract 14 from both sides like this, so I can get it to be 0, right? So the quadratic equation can be used then. So I get 0 equals -16t squared plus 24t minus, okay, so this would be -8, right? That's going to be -8, correct? Okay, now you could use the quadratic formula. To do this quadratic formula, you have to understand that this is A, okay, and this is B. So B is going to be 24, C is going to be -8, and A is going to be -16. But look, you gotta use a little bit of intuition here, okay? All of these numbers are divisible by 2, okay? Heck, they're all divisible by 4. Heck, but they're all divisible by 8. So you can simplify this equation, okay? You can simplify this equation by dividing the whole thing by 8, okay? So if you do that, like this, you divide every single term by 8, you get 0 divided by 8 is 0, okay? This becomes negative 2t squared, that's 3t minus 1, okay? So you get negative 2t squared plus 3t minus 1. Now you can use this in the quadratic formula. So a is negative 2, b is 3, and c is negative 1. Okay, so a is negative 2, b is 3, and c is negative 1. Okay, now you got to substitute this in the quadratic equation. So you said x is equal to opposite of b. b is 3, so you have to take the opposite of 3, like this. Opposite of 3. And when you substitute it all, you get that. So you get negative 3 plus or minus square root of 3 squared is 9, minus 4 times a times c. Negative times negative times negative. There are 3 negatives there. 4 times a times c. Okay, 4 times 2 is 8. First, figure out the sign. See, there's negative, negative, negative. So the 3 negatives, so it's going to be negative. And then do the multiplication, so that way you don't mess it up. Over negative 4. So that's negative 3 plus or minus square root of 9 minus 8 is 1, last time I checked, over negative 4. So that is negative 3 square root of 1 is 1 over negative 4. Now you can divide this into 2, negative 3 plus 1 over negative 4, and negative 3 minus 1 over negative 4. That's negative 2 over negative 4. That's negative 2 over negative 4. That's 1/2. Okay, and that's negative 4 over negative 4, and that is 1. So look, we get 2 answers, half and 1. In other words, when it is 1 second, or when it is 1/2 of a second, the basketball is 14 feet high. In other words, basketball is 14 feet high 2 times. Like over here, it's 14 feet, and like over here, it is 14 feet. Because it's a parabolic function, every height would be achieved 2 times, right? So the height will achieve 2 times. In fact, after 1 second and after half a second, the basketball was released from the hand of this young man. So that's all fine, but that's not what we wanted to know, though. What we wanted to know was, how long will it take for the basketball to reach the ground? Well, the thing to appreciate is, when the basketball reaches the ground, the height of the basketball is getting smaller and smaller and smaller until when it is 0. So when the ball hits the ground, the height of the basketball, the h of t, is 0. Okay? So the thing to do is we have to set this equation, the vertical motion equation, to 0. So negative 16t squared plus 24t plus 6, that is equal to 0. And then we have to solve this equation for t. Now again, we're going to use the quadratic formula. Okay, I can divide everything by, in this case I can't divide by 8, but I certainly can divide everything by 2 to make my life a little easier, right? So at 0 equals negative 8t squared plus 12t plus 3. Okay, then I use the quadratic formula again. And when you solve this out, like I've done over here, patiently, you get 2 answers, 1.71 and negative 0.23. In other words, time when it hits here, the ball hits the ground, is 1.71 seconds approximately. And since we cannot go back in time, it would take actually from here to here would be negative 0.23 seconds, 0.23. And that result is meaningless because we can't go back in time. So what we have realized, it takes about 1.71 seconds for the ball to hit the ground. Inshallah, next time we shall continue with the same problem. Until then, as-salatu wa-salam, rasulillah, alhamdulillah, rabbil alameen, assalamu alaikum.